Hi, welcome back to Leetcode. So in this video, I'm going to discuss Leetcode problem 3759. Count elements with at least k greater values. So the problem statement is that you are given integer array nums of length n and integer array k. Okay. So an element in nums is said to be qualified if there exist at least k elements in the array that are strictly greater than it. Okay, return an integer denoting the total number of qualified elements in nums. Okay, so that means we have to count the number of qualified numbers, so or qualified elements. So which number will be qualified if the count of number which is greater than the current number, that should be qualified. If that count is greater than equals to k, then actually we can say that this number is qualified. Okay, so let's take this example 312 and k value is 1. First of all, I want to know that this 3 actually qualified or not. So how many number is greater than 3? There is no number, so that count is 0. Is it greater than equals to k? Means key value is 1? No. So that means 3 is not a qualified number. Next is 1. So how many number is greater than 1? Strictly greater than 1. 2 and 3. So that means count is 2. It is greater than equals to k. K value is 1. Yes. So that means this is a qualified. Okay. Next number is actually it is 2. How many number is greater than 2? Strictly greater than 2? Only 3. So that means count is 1. It is greater than equals to k. Yes. K value is 1. So it is also qualified. So how many numbers is qualified total? 1 and 2. So our answer here will be 2. So actually you can see that the expected output here actually it is 2. Okay, let's take the example 2. Okay, so duplicate is allowed here. Alright, here actually you can see that the 5 is present 3 times. So we have to think about the duplicate also. So 5, 5, 5, k is equal to 2. So first of all, I want to know this number. So is this qualified or not? First of all, count how many numbers is greater than 5. There is no number, so 0. Is it greater than equals to k? No. Next is this 5 also. Is there any number greater than 5? No. So k value is 2. So this is also false. Similarly for the next 5 also. So actually our answer will be 0. No number actually is qualified. So here actually you can see that if 1 5 is disqualified, then all the other 5 will be also disqualified, right? That means this actually global count. Means we want to know that this 5, how many numbers is greater than strictly 5 in the array, in the input array. So if there is here actually 6, here also it is 7, here is also 8, here is also 9. So for this 5 also we'll count this 6, this 7, this 8, this 9. This 5 also will count this 6, this 7, this 8, this 9. So that's why if 5 actually is disqualified, then all the other 5 also disqualified, right? This is clear. So that means we do not need to check the other 5 also. So this is clear, and this expected output is also clear. Now how actually we can solve that? So we can actually have one input array. Suppose 1, 2, 3, 4. Okay. So for each number, brute force approach, what we can think. So for each number, I will iterate the whole input array again. Okay, and count that how many number is greater than equals to current number. Okay, count how many numbers is greater than equals to x, the current number 1. So first of all, I will start from here. Is it 1 is greater than equals to 1? No. So I'll go to the next number 2. Yes, 2 is greater than equals to 1. So I'll increase the count. It is initialized to 0. Now it is 1. Next I'll go to the 3. 3 is greater than equals to 1. Yes, now it is actually increased by 1. Now it is 2. Next I'll go to the 4. 4 is greater than equals to 1. Yes, count is now 3. So I have reached the end of the input array. So this is the count. How many numbers is greater than the current number 1? 3. So suppose k value is 2. So count is greater than equals to k. So our answer will be increased by 1. Previously it was 0 and now it is 1. That means this 1 is qualified. Next number I will go to the 2. Again I will start from 1. Sorry, I will start from 1 and I will check is 1 is greater than equals to 2. Sorry, 1 is this should be actually strictly greater than, not greater than equals to. So first of all, I will come to this 1 is greater than 2. No. I will go to this 2 is greater than 2. No. I'll go to the 3 is greater than 2. Yes. Now I'll go to the 4 is greater than 2. Yes. So that means count our value for this value, our count will be ultimately 2. And k is equal to 2. So 2 is greater than equals to 2. Yes. So I will increase our answer by 1. Now our answer will be 2. Clear? In this I will check. So for this approach, what is the time of sorting? So you can see that for each number, I will iterate the input array again. Right? For each number to know the count. How many number actually elements are greater than the current number. So how many elements in can be in elements it can be we can actually have, and for each element I will actually iterate the input array again. Length will be n. So for this our time of sorting will be n square. This is clear. Actually it is n square. So it will not work because our n value can be 10 to the power 5. So n square to 10 to the power 10, and maximum it is allowed to 10 to the power 8. Correct? So this will not work, this approach. So how will I optimize this? So we can actually first of all brute force another algorithm which we can think, that actually first of all sort the array. So 1 2 3 4, I'll sort the input array, and I know suppose k is equal to 2. So I'll start from this left to right. Okay, this left to right. So first of all I come to this 1. So I know that current total number actually I actually have 4. Suppose count is 4. Count initialized to the maximum element. So 4. So for this number I want to know that how many number actually greater than 1. So how can I actually do that? So I know that maximum actually I have 4 elements, right? So first of all subtract this current element. So 4 minus 1, because this number will be always same equals to the current number, so we cannot count this. So first of all subtract this number. So count will be now 3. Is 3 greater than equals to k? Yes, 3 is greater than equals to k, because the k value is 2. So this is actually true. So our answer will be 1. Correct? This number 1 is qualified. Now go to the next number 2. Okay, so count previously it was now 3, and now subtract this current number. So now count will be 2. You can also verify that this count indicates that how many numbers are greater than the current number. So it indicates 2. Current value is 2. That means 2 number is greater than this current number 2, 3 and 4. This is valid. Okay. So now I want to check that is count is greater than equals to k. Yes, 2 is greater than equals to 2. So this is also true. So our answer will be increased by 1. Now go to the next number 3. So 3, I have to subtract this current number. Now count is 1. So you can also verify that, cross check that this count will indicate that how many numbers is greater than the current number. So how many number is greater than 3? It is only one number, 4. So this value is 1. That's correct. So 1 is greater than equals to k. So k value it is actually 2. So this is false. So we cannot increase our answer. So now guess next number 4. Okay. So I have to subtract this current number because so here actually you can say the count is 0. There is no element on the right side. So there is no number which is greater than the current number. So our count is 0. So is 0 greater than equals to k? K value it is actually 2. No. So our answer ultimately it is, we have reached the end of the array. So our answer it is 2. Clear? Which answer is 2 for this input array. But this approach will not work for if we have repeated number, a duplicate number. You can also say that something like we will suppose have 1 2 2 3 4. So we have sorted this input array. So count will be initialized with maximum number, this is actually 5. Okay, our answer will be also initialized with 0. Okay, first of all this is the current number 1. Okay, so 1. So first of all subtract this current number. from the count of the greater than equals to current number. So count it is now 4. Okay, so suppose k is equal to again same 2. Okay, so 4 is greater than equals to 2. Yes, so our answer will be also increased by 1. Next, number 2. So before counting that how many numbers greater than this current number, first of all subtract this 1. This is actually 3. Okay, so 3 is greater than equals to 2. But before that, we also cross check this 3. Is this 3 is valid? So I am saying that how many number is greater than 2? It is 3. But ultimately 3 and 4, only these two are actually greater than this current number 2. Like our count should be 2. Right? Our count should be 2 somehow. Because this indicates that how many numbers are greater than this current number. So here it should indicate 2 because I am currently at the number 2. So 3 and 4 it should be count should be 2. Clear? So this approach will not work. So somehow we have to handle like we have to bundle all this number here. That means something 1, 2, 2, 3, 4. Okay. Count will initialize with 5 and our answer will be also initialized with 0 and our k is equal to 2. Same. Now I'll start from here. First of all, subtract this. How many numbers are present in this bundle? Only one number. So subtract by 1. So it is 4. You can also cross check this state. I am saying that there is 4 number which is actually greater than this current number 1. 2, 2, 3, 4. Yes, 4 number. This is actually valid. So k is equal to 2. So 4 is greater than equal to 2. Yes. So our answer will be increased by 1. Now go to the next number 2. So how much should we should decrease the count? It should be decreased by 2 because all actually same. So that's why this should be our count should be decreased by 2. This is clear. Why actually I am decreasing by 2? Because here this count actually indicates that how many number greater than strictly greater than this current number. So these two are actually same. So this actually we have to adjust the count. So by how much we should actually decrease? We should decrease the count of the current number. Current number is 2. Frequency of the current number is 2. So that's it should be decreased by 2. So now count actually it is 2 and k value is also 2. So this is also true. Our answer will be increased by 1. Now our answer is 2. Next go to the 3. So by how much actually should decrease? What is the frequency of 3? Only 1. So it will be decreased by 1. So our count is 1. You can also cross check that I am saying that we actually have only one element which is greater than the current number. Yes, there is only one element 4 which is greater than current number. Now we can say that so these two I am increasing only it should be increased by 2. Why? Because for if these two is qualified, then these two also be qualified. Why? Because we want to calculate the in the input array, in the whole input array, how many number is greater than the current number, right? So I am saying that for these two I actually have two elements which is greater than the current number, that actually 3 and 4. So for these two also I also have two number which is greater than the current element 3 and 4. Clear? So our answer will be also if this and this number actually is qualified, then also our answer will be increased by the frequency of the current number. So frequency of 2 is actually 2, so this will be increased by 2. 1 plus 2 it will be 3. Clear? So you can also check that I am saying that there are 3 elements 1, 2, 2. So for 1 also we actually have 4 elements which is greater than equals to k. For this 2 also we actually have 2 elements which is greater than the current number and that is actually greater than equals to k. For this 2 also we actually have 2 number which is greater than equals to current number and that frequency is greater than equals to k. So our answer should be 3. Clear? So we can actually, to know the frequency of each number, we can actually use the map, right? To store the number and the frequency. Correct? So for this example, what I'll do? So for this example, I will say that for 1 the frequency is 1, for 2 the frequency is 2, for the frequency for the number 3 frequency is 1, for the 4 the frequency is 1. Okay. Now what I'll do? I will start our count with total number. How many total number elements is present? 1 plus 2 plus 1. That means 5 actual elements present. Total 5. So I'll initialize with 5. So I'll assume that all the numbers are greater than this current number. Okay. So before starting of the current this smallest element 1, and our answer will be also initialized to 0, and I know the k value 2. So I'll iterate the map. So first of all, count will be increased by the frequency. Okay, map of I. So if count is, this count indicates that total number of elements greater than the current number. So if count is greater than or equal to k, I will increase our answer by map of I. Clear? Why actually I'm increasing by map of I? Okay, this is clear. So here actually you can say the what is the time study for that. First of all, we will store the frequency of each number. So I have to iterate the input array only one, correct? So that will take big of n. If there is input array length is n. Now for again actually iterate the map. So map size maximum it can be n. So for each position, if we iterate the map, so it will be big of n. And now because why actually n? Because it may possible all the number actually it is unique. It may possible. So that's why our map size will be big of n. And here actually I am using only the constant operator, constant time, because I am only accessing the value of the current map element. And I'll just check that this is greater than equals to k or not. If it is greater than equals to k, then actually increase the answer. So again, this will take big of n only. So ultimate time study for this approach, it will be big of n plus n. So this will be big of n. Clear? So how actually this approach will work. Now go to code. So first of all, I will take one map to store the frequency of each number. So to store that frequency, I have iterated the input array. So I'm iterating the input array nums, and just for against the number, I'm increasing the frequency, okay, by 1. And now I want to know that how many numbers is greater than the current number. So I have initialized with the nums of input array length, nums dot size, okay, and answer it is initialized to 0. That indicates that how many actually it is number actually it's qualified, okay. Now what I have to do, I have to iterate the map. Why actually I iterated the map? Map will store all the numbers in a sorted order. I know that first number I will get as 1. Map element it will store the key value will be 1. Okay. So first what I have to do, I have to decrease the count. Why I have to decrease the count? Because I want to know the number is greater than the current number, exactly greater than the current number. So this current number should only part of that. So that's why first of all subtract that from the frequency or the count. We have already have total. So count will be decreased by I dot second, the frequency of the current number, because we may actually have the duplicate number, right? So that time we should actually adjust that. We have to adjust the total number of count which is greater than the exactly greater than the current number, strictly greater than the current number. So that's why I'll decrease the current frequency of the current number. Okay. So if this count is greater than equals to k, that means this number is qualified. Correct. This number will be qualified. So I have already explained that if one number of the current in the current element is qualified, then all the other number of the same element will be also qualified. Like if 1 5 is qualified, then other 5 also will be qualified. Correct? Because we will only count in the global or the input in the whole input array. So that's why if count is greater than equals to k, I will increase the answer by the frequency of the current number, because all the number will be qualified. If one number is qualified, then all the number will be qualified of the same value. So that's our answer will be increased by whatever the frequency is present. Got it? So in this actually we will check all the elements of the input array, and we'll check the count, adjust the count, and we'll check that if it is greater than equals to k, we will increase our answer. Otherwise, we go to the next number, and ultimately return the answer, whatever the value actually we actually have after finally in the answer variable. Got it? I hope this is clear. You have any doubt, any suggestion, you can comment on that. And I have shared this code in the description. You can check that also. Bye. Thank you.